Your job is to write a formula for this. K is proportional. K is proportional to what? To the square of velocity. So here's velocity, here's the square of velocity, and it is proportional according to some constant. Some constant, oh, let's call it C. But as soon as I put in that proportion, that constant, I can write the equal sign. So K equals C times V squared. So the next one is to write a formula for this. F, the gravitational force. The gravitational force, F. This guy is what? Well, it's inversely proportional to something. So it's going to be proportional, so there'll be a number there, and it's going to be inversely proportional, 1 over something. Inversely proportional to the what? To the square of the distance d between the two bodies. So here's the distance, and here's the square of the distance between the two bodies. And of course, that's going to be multiplied against some constant. I can write C or K. Now I'll write K. So K times 1 over d squared. That means the gravitational force F is proportional by virtue of some constant K to 1 over d squared. It's equal to K times 1 over d squared. So it is, F is proportional to the inverse of the distance squared. And here's our guy. So now write a formula for this. Average velocity v over a fixed distance d is inversely proportional. Okay, let's grab the first part. Average velocity v is inversely proportional over a fixed distance d. It's inversely proportional to travel time. So there's the travel time, and over a fixed distance d times 1 over t. So here it is, average velocity is equal to distance times 1 over t, or d over t. So write a formula for this. The volume of a sphere is proportional to something. So there'll be a constant here. Proportional to the radius cubed. So the constant is k. Now you may already know this, but I happen to know that k is 4/3 pi. So volume is equal to 4/3 pi r cubed. That is the k, the actual k. Well, let's sketch this graph. 1, it warmed up in the morning. Then it suddenly got cool at noon. Then it warmed up again just before sunset and cooled at night. That would be a possible graph. So here's our next problem. We're going to graph this. A guy rides a bike. Well, the trip is going to be for 10 miles. So there's our 10 miles over here. He's going to ride this bike for 10 miles. All right? Let's get rid of this. It's going to be at a constant speed. He's riding until he reaches a hill at a 4-mile point. So he's going along at a constant speed till he hits 4 miles. At 4 miles, he runs into a hill and he slows down. And the hill peaks at 5 miles, so he gets to the top of the hill and rests. He's really slowing down. All right, he hits the top of the hill and he rests. And now what does he do? Well, now, that was 4, 5, 6, and this will be 7. So here he's going at constant speed. He reaches the hill at 4-mile point. Here's point 3. I'll put that in red. And then it peaks at 5 miles. So here he is at 5 miles. Now he's resting. Now he goes down the hill for 2 miles. Now, that means he's going to be going fast. He's picking up speed. 2 miles. And he hits the 7-mile point. He's going downhill for 2 miles. He's at the 7-mile point now. Now the last 3 miles are flat land. So he's not going fast anymore. He's going to be slowing down. At least a little bit. So he'll start to slow down. And stay at about a constant, and then he gets to the end and boom, end of the race. And that's it. Well, that's it for now. Time to draw the smiley face and say so long. So long now.